So today is the last lesson that we're going to be going over, or at least new material. We'll still test will be Tuesday, because I try to keep with the testing schedule, but just with how the sections fell, it's going to be a little bit of a rush trying to do that. And I do want to cover what we're doing today. Now, are there any questions on the homework before we start this? For those of you I don't think were in here yesterday, two of the problems from last night's assignment, you do need the quadratic formula to solve. Our negative b plus or minus the square root of b squared minus 4ac all over 2a. You'll need this for two of them because the constant term works out to be e to a power. It's not a nice number, so we have to use the quadratic formula to find it. Are there any questions? Now, what we're doing today is very similar to yesterday, except we're going to be talking about inequalities. Now, there's no real big change for exponentials where x is in the exponent, and there's no real restrictions on anything we're going to be doing. So if we looked at, say, 3 to the x, and we graphed it, well, it works for all values of x. So I can plug any value of x in to an exponential when x is in the variable, or x is in the exponent, not variable, x is in the exponent. We can plug any number in. We can plug positives, we can plug negatives, we can plug 0, we can plug irrational numbers, we can plug any number we want in, and it works just fine. Now, I'm going to do the inverse of 3x, so log base 3 of x. And if we graph this here, we notice that at the y-axis, when x is 0, anything to the left of that, any of the negative numbers do not have a spot. There is no value. And if we look at the table, 0 and above, or 0 and below, 0 and negatives, we have an error. We cannot have 0 or a negative number inside the logarithm. And we've talked about that before. Now, when we talk about solving inequalities with logarithms, we have to take that into account. And we'll see that when we get there. But with exponents like this here, we don't have any restrictions on the domain. We don't have any restrictions on the values of x that we can have. Now, just like yesterday, if I want to get the x out of the exponent, and since the base is 3, we're going to use log base 3. So the x would go to the, and log base 3 of 3 is, it cancels, it's 1. So this simplifies x is out front, just leaving us with x is. Yeah, so x is less than log base 3 of 20. Now we just need to find out what this is. So the graphing calculator, we can say math log base 3 of 20, which is 2.726, or if we round to the nearest third decimal place, we get 7. And this is it here. So as long as x is less than 2.727, we do have a true statement. It does work. We'll get there here in a second. Questions on this here? We ready for the next one? E to the x is less than. So what would we apply to both sides? Now the x would move to the front, telling us that we have x ln of e. Well, ln of e is 1. So we have x is less than ln of 2. Well, at this point here, we just need to evaluate the natural log of 2. Natural log of 2 is So as long as we have something less than 0.693, we will have a true solution. Questions on any of this here? So what would we need to do first? Log base 10, or, right, so we can just write it as log. Because if the base is 10, it's understood, so we can just say log. Now the 2x minus 6 would move to the front. And we could just leave it as 2x minus 6, because log base 10 of 10 is 1, or just log of 10 is 1, giving us 2x minus 6. What can we do next? We can, or, yes, I would wait to the very end to do any calculations. The only time I would say to plug anything into the calculator and simplify it is if it simplifies nicely. So if log of 3 had simplified to a nice number, anything that does not have a non-repeating, non-terminating decimal, go on and do it. But here, log of 3 is not going to be a nice number. So we'd add 6 and then divide by 2. X is greater than log of 3 plus 6, all divided by 2. Now at this point here, we can plug it into either calculator, because log of 3 plus 6 all over 2 is 3.2385 or 3.23. And that's it. Questions on any of this here? We feel pretty comfortable with logarithm, or exponentials, really. And exponentials, again, don't have any restrictions on what value x can be. It can be whatever it needs to be. Positive, negative, 0, irrational. So any of these will work. Now logarithms, and again, x here is what's inside the logarithm. As we said earlier, that the log of x cannot be 0 or negative. So the first thing we need to do is set whatever's inside the log to be greater than 0. We're finding our restrictions. But x cannot be. Well, x has to be what? Greater than 0. Because there's nothing else inside the log. If we had the log of x plus 4, we would set x plus 4 greater than 0 and solve for the value of x. Here, x is just greater than 0. What would we do next? So x is less than or equal to 10 squared, which is 100. Any questions on how we solve this here? Okay. Now the question is 0 less than or equal to 100? Is 0 less than 100? Yes, isn't it? If the numbers or solutions that our restrictions are a part of the solution, we have to include it. So here we have to say that x is 0. Yep. So 0 is less than x is less than or equal to 100. We have to add that restriction in. Now, if it didn't come into play, so I'm going to get a different color. Let's use this color. If instead it was x is greater than or equal to 100, well, is 0 greater than 100? No. So that would be it. Because 0 is not contained in the solution, we don't have to include that part. Does that make sense? Can we see the difference between these two? Can we even see the other one? Yeah. But that's it. If 0 here, 0 or negatives was contained in the solution, we had to exclude it. If they're not contained in the solution, we don't have to exclude it. So again, this here, it's understood that without the parentheses around the x plus 9, the only thing contained inside the log is x. If it wanted to say that x plus 9, both of them were included, it would have written them as this here. Does that make sense between them? Now, on the test and review, I will put the parentheses around what's inside the log so that we understand what is, and not just based off understanding this here. Now again, we can start off by finding our restrictions. So we set what's inside the log greater than 0. Well, that's just telling us that x is greater than 0. Okay, now we can start solving. Well, before we can put both sides to a base, we need the log by itself. So you can subtract 9 from both sides. So the log of x is less than 36. Now we put both sides to the base of 10. 10 to the log of x is just how many zeros does 10 to the 36 have? Almost. 36, yeah. Because 10 to the first has 10 squared has, it's the exact same as the exponent.
10 with 36 zeros.
With this here and on the homework, if it has more than 6 digits, leave it in exponential. If the answer has more than 6 digits, leave it in exponential. Because here we're going to have 37 numbers, but 36 of them are 0. Now, is 0 less than 10 to the 36th? Yeah. So we have to include the fact that 0 is less than x is less than 10 to the 36th. And that's it. Questions on this here? Yes, we can add 1. Telling us 2 ln of x is greater than 5. Divide by 2. Telling us that the natural log of x greater than. Now what do? We would put it to the base of e. Because e and ln would x is greater than e to the 5 halves. .182. It's on both calculators. It's attached to ln. So most every calculator, it's second, and then the ln button will give you e. Even if it is e to the first, you still need to put it in the calculator as e to the first. It wants an exponent with it. Now, our restriction, we didn't say it at the beginning, but x was by itself inside the log, so x has to be greater than 0, yes? Is 0 greater than 12.182? 0 greater than, no. So since it's not bigger than it, it doesn't make a true statement when plugging it in. We don't have to include it. Because every number greater than 12.182, well, every number greater than this 12.182, make this 2, yeah, so we don't have to add it. Because on all the previous ones, here, so this here x is less than it. Would -1 be less than 10 to the 36th? Over here is -1 greater than 0. So we have to add this here because we can't have a negative value inside the log. So we have to add the restriction if it comes into play. Here, x greater than 0 is not going to make a difference because it's always going to be true. We don't have to add that. Does that make sense? Because it's 0 greater than 12. So is there any way I could get 0 inside the log? No, so I don't have to have it. Any other questions on this here? Are you ready for, do we feel comfortable with these exponentials? Yeah. So we subtract 3 first. Yes. What's 30 divided by 5? Mm-hmm. Then what would we do? All right, we would move it out front, but to do that, we need to apply the natural log to both sides. Now this here became this because ln of e is cancels out, it's 1. Yes. Notice that x squared is less than the natural log of 60 minus 4. Yeah. Because it would tell us x is less than the square root of the natural log of 60 minus 4. But whenever we take the square root of both sides, we have to add the plus or minus, yes. But because we changed the sign of one side, we have to flip the inequality sign. Yes. I'd plug it all in at once. So 0.307. So x is less than 0.307. Well, all we did was put a negative in front of it, so this is going to be negative 0.307. I did that on purpose. Because since we changed the radical from positive to negative, we have to flip the sign to adjust for that change. So really what we're saying here is that negative 0.307 is less than x is less than 0.307. We have a very narrow window of where this actually works. So 0.3 would technically work in this. So if I did 5e, or we can say 0.3 squared plus 4, and then what was it? Plus 3. We get 301.6, which is less than 303. So that works. Get the decimals back. Now, what's interesting is if we do 0.31, we're now greater than 303. It's not true. So there's a very small window between those 2 points where the solution actually works. But we won't have one as,
Complicated as this.
really it's not too complicated until we get to this point here where we square root. The rest of it's fine. Any questions on this here? Let's do this one here. Now I'm going to put another set of parentheses for this one here. I want to do this one, the one before it. I actually did the other 2 hours. So if you want to see that one done, I do have it in the video for those. Before we start solving, the first thing I'm going to do is move the 4 to the front. It's going to make it a little bit easier to work with. These will cancel, telling us the natural log of x minus 8 is less than. Now what do we need to do? Apply e to the both sides, because e and ln will cancel. Minus x minus 8 is less than e to the first. Yes. X is less than e to the first plus 8. Give you all a second to catch up. Now, with e, we still have to put first. 10.718. Is what we have. Now, we did forget to do this. I forgot to do this, is our restrictions. What's inside cannot be 0 or negative. Now, we would add 8 to both sides. X has to be greater than 8. Now, we can check this here, because this one here actually does work out a little funny. Because it's natural log. Lost track of it. Natural log, parentheses, x minus 8 to the fourth, and close parentheses. Now, we won't put the greater than, but we know that what's inside here, what's inside for x, just for this here, has to be greater than 8, yes? Graph. Wait a minute, I do have values that are of x that are less than 8, yes? And the reason I say this, or kind of bring this up, now one of these won't come up on the test or review. Anything to an even power is positive, yes? So all the negatives that we should get because of this fourth power are now, so it takes care of any of the negative cases. But this still here has to be what? It can't be 0. It can't be 0. Well, we see that it does work out. But let's see what happens at 8. Because at 8, we have 8 minus 8, which is 4th root of 0 is still 0. It can't be 8. So really at this point here, we're saying it can't be 8. Yeah, this one here is the only one that's really complicated with this. Yeah, so we have to get rid of 8, which is kind of hard to do with inequality notation. We could do it with intervals, because it'd be negative infinity, comma, 8, union of 8, comma, 10.718 would technically be the solution. We have to pull 8 out, because 8 is the one solution that doesn't work. It's a funny notation, but everything else would work. Go in the other direction. Does that kind of make sense? It's weird. This one's funny, but we don't have anything like it on the homework. Because the ones on the homework are actually kind of nice.